Good afternoon, everyone. Am I audible? All right. OK. I love to travel, and I thought I would start with a journey trivia as people settle in. OK? If you had to avoid the busiest airport in the world, what would that be? Sorry? Right. It's Atlanta International Airport. Do you know this airport saw more than 100 million passengers in 2015? Next two on the list are Beijing and Dubai, just so you know. All right. My name is Shon Shah, and I'm a program manager on Virtual Machine Manager team. Virtual Machine Manager is one of the 7 components of System Center, which is a suite of IT management products from Microsoft. Simply put, System Center is for IT admins or IT pros, what Microsoft Office is for knowledge workers. As for me, I have been in the industry for 18 years and had the privilege to work with companies like Novell, Amazon Web Services, and Microsoft. Over the course of next 60 minutes, I would like to take you on a journey of how you can manage software-defined data center using VMM in System Center 2016. At the end of this journey, I hope you will walk away with a solid understanding of how to leverage all the capabilities that we have introduced newly in the 2016 release. We'll keep the agenda simple. We'll start with the overview of VMM, take the journey, and then summarize. We have a lot of content to cover because we'll take 8 stops on the journey. So please hold on to your questions till the end. And I'll be here after the session, and I'll be here for the rest of the conference, too. You can visit the VMM booth. We have a VMM booth in the expo hall. So by a show of hands, how many of you are already using some version of VMM? Wow, excellent. So we will breeze through the overview section because most of you already know this. But for some who don't know it, I just wanted to make sure that all of us are on the same page. Fair enough? OK, so what is VMM? Basically, it is an infrastructure provisioning and management solution for virtualized data centers. It started about a decade ago for enabling the full VM lifecycle management. But over the years, it has added a lot of functionality, like provisioning Fabric, deploying and servicing multi-tier applications, enabling self-service via cloud abstraction, so on and so forth. There have been many releases also, from VMM 2007 to VMM 2012 R2, major releases. On top of VMM 2012 R2, we had quarterly updates, or update rollups, as we call them, the latest being UR11 in August this year. The latest major release is the VMM 2016 release. VMM offers a lot of breadth as well as depth. Even with the 2012 R2 version, as you might know, you can accomplish a lot. So let's quickly take a look at this functionality before we start the journey. We'll start with Fabric. You can do management of compute, storage, and networking. For compute, you can do Hyper-V, ESX. Storage, SAN, NAS. For networking, bunch of vendors. In fact, these are some of the partners that we already work with for storage, networking, and other extensibility points that VMM has. For VMs, full VM lifecycle management, anything and everything you can think of, start, stop, and whatnot, right? Not only for Hyper-V VMs, but for ESX VMs. Live migration of the VM, live migration of the storage, migration of VM from ESX to Hyper-V. A single instance of VMM supports up to 25,000 VMs on 1,000 hosts. Next, intelligent placement. Many times I get asked this question, if I have Hyper-V Manager, or if I have a failover cluster manager, do I really need a management product or solution like VMM? You definitely do need it when you are doing things at scale. So this is one of those features. So basically what we do is we match the requirements of the VMs with the resources of the host and give you a very simple, easy to understand star rating. It is like star rating for the movies, right? 5-star movie, best movie. 1 star, not so much. Applications, you can deploy multi-tier applications using VMM. And this is template-based, so you define your intent in a template and then just deploy it. For authoring the template, we have a designer interface where you can drag and drop your multi-tier application. Self-service, you can create cloud abstraction, so compute storage and networking is sort of invisible to the end user. End user doesn't care about it, and then offer it via Windows Azure Pack or WAP on top of SPF. VMM also has role-based access control. You can say that John is a host administrator and Mary is a storage administrator. For self-service users, you can go even more granular. You can say Peter can start and stop VMs, but cannot create checkpoints if you want to save on the storage that you have. So with that, let's come to the Journey Trivia 2. If you had to visit the tallest building in the world, what would that be? Where would you go? Dubai, that's correct. Burj Khalifa in Dubai stands little over 2,700 feet. How about US, anyone? Sorry? Chicago, not really. New York, right. It's the one World Trade Center. It is little over 1,700 feet. OK, so we looked at the overview of VMM 2012 R2, right? And there are a lot of features. So you may ask, right, so why should I upgrade to VMM 2016? Or why should I install and use VMM 2016? Fair question to ask. And that's where this journey comes into picture. So as I mentioned, the 8 stops that we will take on this journey are 8 of the many reasons why I think you should consider using VMM 2016. We'll follow a logical sequence, or at least what I think to be a logical sequence. And hopefully, you will see more and more value add with each stop of the journey. OK, so let's start with the first stop, upgrading host clusters with 0 downtime. 0 downtime being the keyword. Let's say you already have VMM 2012 R2 managing a bunch of Windows Server 2012 R2 clusters. You can upgrade VMM 2012 R2 to VMM 2016. I'm not going to cover that here, but that also can be done with near 0 downtime. Once you're on VMM 2016, then the first thing that you would like to do is to upgrade your host cluster to the latest version of the OS. And this is how it looks like. This is a 4-node 2012 R2 cluster. First, what would happen is that all the VMs on one of the nodes will be live migrated to other nodes in the cluster. We call it evacuating the node. Then we evict the node from the cluster, do a clean install of 2016 OS, add the node back to the cluster, migrate the VMs back, rinse and repeat for the other nodes in the cluster, and finally change the functional level from 2012 R2 to 2016. So these are a lot of steps, even for a 4-node clusters. Think about 16 or even 32-node clusters. All of these steps that I just described are accomplished by one ribbon action in VMM. Let's take a look at that. OK, I'm in VMM 2016 console. I have a bunch of hosts. Right now, we are going to take a look at the 2012 R2 cluster. This is a 2-node cluster. By the way, this is a live demo. I like to do live demos. So hopefully, the demo gods are with me. What we are going to do is we're going to look at the infrastructure first. I also have a Pixie server, pre-execution environment, or also called as WDS, Windows Deployment Service Server. This would be used to deploy the OS on the nodes of the cluster. Let's take a look at the library space. In the profiles, I have 2 physical computer profiles, one for 2012 R2, one for 2016 RTM. Let's take a look at that. Here, I have specified a Windows Server 2016 VHD and some hardware and OS configurations. So with that, you have Pixie server, you have physical computer profile, and a 2-node 2012 R2 cluster. Let's go back, right-click on the cluster, and say upgrade cluster. It will ask you how many nodes of the cluster you want to upgrade. And this comes handy. If it is a too large a cluster, right, you might want to try it on a couple of clusters, couple of nodes of the cluster, if you wish. I'm going to select all. It asks for the physical computer profile. Here, you will notice that it gives a nice little warning saying that, OK, the profile that you have selected matches the OS, which is already there. It's like when you are trying to type a password, a little note comes up saying that your caps lock is on. So I'm going to select VMM 2016, say next. These servers need to have BMC IP address, baseboard management controller. This is how the servers will boot and get the VHD from the Pixie server. And for that, it needs the BMC run as account. I'm going to pick one. You can use IPMI or Smash. We support both. I'm going to use IPMI. Next. Now, what it's going to do is look at the nodes of the cluster. And since I haven't done the bare metal deployment on these servers, it's going to ask me for the BMC IP addresses. So let me specify one for the first, 10.21 for the second. Next, it will give you a nice little summary. As you might know, there is a view script button, which will spit out a PowerShell script, VMM PowerShell script, in case you want to automate the same action, and finish. Soon you will see that the host will be put in the maintenance mode, which means the node will be evacuated, then evicted, then OS would be deployed, added back to the cluster, and same thing happens for the second node in the cluster. Second stop, create tamper-proof virtual machines. Now you have Windows Server 2016 cluster. You upgraded from 2012 R2. What are the new shiny things that you can do with 2016? This is one of them. Actually, it is really a differentiator for Microsoft, I would say. So let's first look at what is a tamper-proof VM. These are called shielded VMs. Shielded VM is a VM whose data, either at rest or in transit, cannot be snooped or tampered by either the malware or the admins. And the data center admins do not have to be malicious admins. Sometimes, right, you require this accidental protection also. So if you think about it, as they say, hindsight is always 20/20. It's really interesting to see that how did we survive so far without a functionality like shielded VMs? Because if someone is a hoster and I'm a tenant, I'm creating a VM on the hoster's infrastructure. Now the hoster admin has full access to my data, and we'll see that. So what are the prerequisites? Shielded VMs is a topic in and of itself. Actually, that's true for many topics that I'm going to cover, be it in networking or storage. And there are dedicated sessions for each of these. But I'm going to try and focus on what VMM adds in the whole picture. So I'm going to gloss over some of these details, but hopefully you will get the idea. So for shielded VM prerequisites, the hoster starts with a VHDX, runs a tool called Template Disk Wizard. This is a tool that ships as part of Windows Server 2016 and creates a signed VHDX. Now, why is this needed? This signed VHDX is something that you as a tenant can get and create the VMs and make sure that you are OK with this VHD. The hoster will make this VHD available in the VMM library. On the tenant side, what you do is you run this another tool called Shielding Data File Wizard. So what is this shielding data? The extension for this is PDK, so sometimes we refer to it as PDKs. So let's say you're going to create a VM. During VM creation, right, many times you specify the local administrator password or the RDP certificate. Well, let's think about it. If I'm going to create a shielded VM, but if I give the local administrator password in plain text to the hoster, then I would be defeating the whole purpose, right? So by using the shielding data file wizard, all you do is you create like sort of a bag of data which is opaque to the hoster. Because it's in encrypted format, only you can look at it. And then you upload this to the hoster. And now in the VMM, you can create a shielded VM using the signed VHDX and the PDK data. So how does it actually work? So let's say you request the shielded VM to be created. And now the host wants to start the shielded VM. Now, any host cannot start shielded VM. It needs to be a designated host. And for that, right, there is a role in Windows Server 2016 called Host Guardian Service. This is a new role, and it has two functions. One thing is attestation. Another thing is key protection. So this service, Host Guardian Service, is a trusted subsystem. And this is what says that, OK, this host, right, I'm going to measure it. I'm going to attest it if it is OK for that host to start the VM. So the host says that, OK, please attest me, gets back the certificate. And now the host says, OK, I have this shielded VM I need to start. Give me the keys so that I can decrypt and start the shielded VM. The attestation service checks whether it is actually attested or not, gives back the keys, and now the host can start the shielded VM. So the whole idea is that the host on which the VM is running is also ensured to be guarded and attested so that the malware cannot tamper your VMs. So, OK, you can create shielded VMs, but you're not going to create all the new VMs, correct? You might have existing VMs. So for that also, we have something called as grandfathering or shielding an existing VM. This is how it goes. The hoster starts with the Windows Server 2016 VHDX, creates a VM. Wow, this clicker is interesting. Creates a VM so that the spatialization happens. And on the VHD, he runs a command. This is a PowerShell commandlet which is already available, and creates something called as shielding utility or shielding helper VHD. And then you specify that in the VMM global settings. Okay? This is a one-time action that the hoster needs to do. That you as a tenant do not need to do this. And the reason this is needed is there is a lot that goes behind the scenes. In fact, when you shield an existing VM, another temporary VM gets created using this shielding helper VHD. And then the OS disk of the VM to be shielded gets bit-locked for encryption. So all these details are there in the TechNet documentation. But I just wanted to quickly mention that. On your end, you start with a regular VM, create a PDK, and then use the regular VM and PDK in VMM to shield an existing VM. Just a quick tip, the PDK for creating a new VM, new shielded VM, and shielding an existing VM are different. So you cannot use one for other. And VMM makes sure that it lists only the appropriate PDK when you create a new or shield an existing VM. let's take a quick look at the demo. OK, so I'm going to look at all the hosts. As you can see, there is a guarded column. I have 3 guarded hosts. OK, how did these become guarded? For this, first you go to the settings space in VMM. Then under General, you go to Host Guardian Service Setting. This is new in VMM 2016. The 2 key functions of HGS that I mentioned, the attestation server and the key protection server, these are the URLs that you specify in VMM. You have to set HGS outside of VMM. And then the shielding helper VHD is specified here. After that, sorry? Correct. The host guardian service should be outside the VMM because it's a really very critical system. That is the system which says this host is guarded, this host is not. I was about to say this, but I did not. Actually, we do have a template, the service template in VMM, which you can use to deploy the host guardian service. But it will be deployed on a set of VMs. And that's not a recommended practice. But yes, it needs to be a separate system. OK, let's get back to the host. And in the host, if I go to the properties and host guardian service, here you click a checkbox to make sure that now this host can use the URLs that you had specified in the global settings. And if you come to the status, it tells you whether the host is being guarded or not. So if you are having any issues, it's a good idea to check at the status. If something is wrong, in the error details, it will tell you what might be wrong. OK, now let's look at the library. I have some templates. I have a bunch of templates here. Let's look at the template which has a shield icon. Look at the properties. This is a shielded template, and it is shielded by the virtue of using a signed VHDX. So this is the one that, that was signed. Apart from that, the template pretty much remains the same. I also have the shielding data, as I was mentioning, and this you just upload to the VMM library. Now let's go back to the VMs and services, create a new virtual machine, use an template. So shielded template, OK. Next, demo shielded VM. Next. Other thing that you would want to do is ensure that this VM is connected, and I will come back to it in a bit. Next, you will notice that it won't ask you for administrator password. And that's because in the next step, it is going to ask for the shielding data file. And if you browse, you would notice here that in the library, there were 4 PDKs, but here it is listing only 2. And this is what I was mentioning. It already filtered out the PDKs for grandfathering or shielding an existing VM. So I can say create new shielded VM. Next, destination, hosts in Seattle. Here, you will notice that there are a bunch of hosts with 0 stars. And let's look at the reason why. You will notice that if the host is not guarded, it automatically gets 0-star ratings. Next. I'm going to keep the remaining settings as it is. Next. And create. That's it. It will create the shielded VM for you. One thing to note about shielded VMs is you cannot do a console connection to shielded VMs. So I have a shielded VM. And if I try to connect to it, the console connection is not allowed. And this is one of the security measures. but you can connect using the RDP. And this is what I was saying, that when you create a VM or after you create a VM, make sure that it is connected to a network so that you can RDP to it. The other question that, go ahead, please. What happens if RDP breaks? You are out of options at that point in time. But in that case, what you can do is you can take the shielded VM, and there is a way to unshield it to make sure that you can fix the issue. So there are ways to do that. The other thing, right, which is about to come is that shielded VM is a black box, which is great because now it is tamper-proof. At the same time, right, it is not good from the troubleshooting perspective because let's say you're a host or I'm a tenant. I created a shielded VM, and during boot it is having some problems. Now you won't be able to help me because you cannot get to the console of the VM. You cannot see the boot screen, right? For that, based on the feedback, right, what we did was we introduced another sort of level of security, which is called encryption supported. So this one, security summary is shielded. The other one is encryption supported. So for these VMs, you can actually connect to the console. Okay? And I was mentioning, right, even if you shield a VM, there are ways where you can take it to the host, which has the owner key. I won't go into those details, but you can sort of unshield it and make sure that everything works. The other question that I get is that, OK, how do I enable the RDP? So when you create the shielding data file, you can specify the unattend.xml, an unattend file. And that's where you can say that the RDP needs to be enabled. OK? So what I'm going to do is I'm going to look at this scenario where if a VM is shielded or a VM is not shielded, what bad or good can happen. So let me look at the regular VM. This is unshielded VM, its properties, hardware configuration. And I'm going to go and do something evil. OK? I'm just going to copy the VHD path of that VM and go to the disk manager. And I'm just going to mount that VHD. OK? Obviously, I know it is on host 2, if someone noticed. So I'm just going to give the UNC path. I was able to mount it. Not only that, I can actually explore the VHD. And there is this interesting folder with the secrets there. So you just got the access to the tenant's data. Okay? Let's try to do that with a shielded VM. So I'm going to pick this shielded VM. The thing that, if you have noticed, I'm using a stopped VM because you cannot mount a VHD of a running VM, just in case you were curious. So same thing. Now I'm going to use the same VHD path. Both the VMs are on the same host, by the way. Go back, mount, attach VHD. You will notice that it is BitLocker, and you cannot access it. So one question that I get quite often is that, OK, what can you then format this? The answer is yes, you can format it. So there can be data loss, or there can be sort of, in a way, denial of service, but there won't be information disclosure with shielded VMs. Okay? I mean, for that matter, right, I mean, if someone really wants to create trouble, right, they can sort of shut down the host on which the VM is running from that perspective. OK, so we look at shielded VMs. Let's get back. So let's take a turn in the journey now. We looked at upgrading the host cluster and then the shielded VM, which is sort of assurance/security part. Let's focus on the storage part. And this is where the software-defined part of data center comes into picture. So Windows Server 2016 has this new feature called Storage Spaces Direct, or S2D. Basically, you can take industry standard servers with local storage and build a highly available and scalable storage using that. Actually, right now, there is a parallel talk going on which focuses only on S2Ds. But as I mentioned, I will focus on the VMM aspect of it. So there are two kinds of S2D deployments. One is called disaggregated. This is where the compute cluster and the storage clusters are separate. So the benefit here is that if you want to scale these independently, you can. Typically, in the larger organizations, this is the deployment option which comes handy because you want that flexibility. The other one is called hyper-converged, where the compute and storage are co-located. So the scaling happens in lockstep. So if you want the simplicity or for smaller, comparatively smaller deployments, we see this as an option. But this is a very powerful option. Now think about it. You don't have to worry about SANs and then shared JBots or like Fiber Channel or iSCSI and whatnot. You just have a bunch of servers, put them together, and then create a S2D cluster, and you're done. So how does VMM help? So you can start with a bunch of hosts with local storage. And there is a wizard in VMM to create a SOFS or scale-out file server cluster. And there is one checkbox that we have added there. That's it, one checkbox which says, OK, use S2D. And at the end, you get this. And let me take a moment to explain this, actually. At the bottom, you have the servers with the local storage. Then software storage bus is what is there in the Windows Server 2016. On top of that, a storage pool gets created. So this is a logical grouping of all the physical disks that are there. And we also auto-configure something called as tiers. So these tiers are nothing but based on the media type and bus type of your disks. You can say that, OK, for my frequently accessed data, put it on a performance tier, for example, SSD. Or if it is not so frequently accessed, then it can be pushed to a capacity tier. So all of this gets configured for you using that checkbox. And then on top of that, you can create virtual disks and volumes on which you can store the VHDs for your VMs. So when you go through this, up to the tiers are created. And then you can go to the cluster and create a volume when we automatically go and create the virtual disks. Similar is the case for hyperconverged. You start with the host. Now you use the regular Hyper-V cluster creation wizard. Again, check a checkbox, and you will get a hyperconverged cluster. The thing that you will notice here is that on top of cluster shared volumes, you also see the VM. So the same cluster is going to run the virtual machines also. Let's take a quick look at this demo. Going to the fabric space. And in Atlanta host group, I have 3 standalone servers, with each having some disks. This is a small environment, so 2 disks each. So what I'm going to do is going to home and just going to say, create a Hyper-V cluster, cluster name, demo HC class. Choose the host group. And this is the single checkbox that I was talking about. It also tells you that it will automatically configure the global pool, the storage pool, and the 2 tiers, 2 or less based on the media type and bus type of the disks that you have. This is the run as account for creating the cluster, so local admin account on the servers. You can start with the host which already have the OS, or you can do this from bare metal also. This is another thing. Like you can start from bare metal machines and go to fully functional hyper-converged cluster using VMM. Just going to say next. Select all the hosts. Next. These servers are configured with static IP address. So we need one IP address for the cluster IP or cluster name itself. I'm just going to let it pick one from the pool. If I want, I can specify one. Don't feel like typing too much right now. And that's pretty much it. Now it will go ahead and create a hyperconverged cluster. It will take some time because it will enable a bunch of features, failover clustering feature, and like dedupe and a bunch of storage features. It will run cluster validation also. I already have two clusters pre-created. So here, if we see in the properties of the cluster in the shared volumes, this cluster already has some volumes. On the other also, is similar is the case, but I'm going to go ahead and create a new one as demo. So I'm just going to say add a new CSV or cluster shared volume, create volume, demo volume. Next. Size 100 GB seems OK. Yes, I do want to configure the tiering settings. And this is what I was mentioning. It had already configured two tiers, one for capacity and one for performance. And now you can split, like how much of you want to use for capacity versus performance. Next, finish. That's it. It has kicked off job. It will take time for the cluster to be created, but for the volume to be created. But you can see that the volume creation has already started. So, and how do these volumes look like? We can look at it in the storage classifications and pools. So this was the first cluster, and these are the three volumes that I showed you. This is just another view for the same cluster, and this is the demo volume that I just created. All right. Let's switch to the PPT. Aha, another journey trivia. If you were to visit the highest waterfall in the world, where would you go? Venezuela, exactly. It's the Angel Falls, little over 3,200 feet. How about US? Sorry? Yosemite, that's right. So Angel Falls has a vertical drop of little over 3,200 feet. Yosemite in California has little over 2,400 feet. If you noticed, these are much higher numbers than the highest or the tallest building in the world. A humble reminder that nature is ahead of us. OK, so next on storage. So let's say you created the hyperconverged cluster, everything is fine. How would you make sure that you maintain the quality of service for your VM storage? So what is the quality of service? So for, let's say you have two VMs, and probably all of you know by this time, right? There is this noisy neighbor problem. One VM can sort of access your storage, and it eats up all the bandwidth and IOPS, right? So this is a feature where for SOFS cluster, you can say that a VM's VHD can take only minimum and maximum IOPS, and this is the bandwidth. This is how it works. In VMM, storage quality of service is a first-class object. You associate it with a storage array, and it gets applied to a VHD. You can associate more than one policy to the same array, or the same policy can be associated with more than one arrays. So basically, it is M-to-N relationship. However, a single VHD can pick only one policy. Okay? So once you set this up, you create VM as you create normally, and then pick the policy, and the policy will be enforced for you. Let's take a quick look. So I'm going to go to the fabric space. And under fabric space, I'm going to go to the QoS policies. And I'm just going to say create a policy. I'll say it demo policy. Next, the policy type, right? basically, you can say this is a dedicated policy or an aggregated policy. By dedicated, what it means that it will get applied to that particular VHD. By aggregation, it will get applied to all the VHDs. An important thing to note is that once you create a policy, you cannot change the type. So be careful. Obviously, you can create another policy with the other type. Min IOPS, max IOPS settings. And if you don't want to enforce any settings, you can just enter 0. All these instructions are mentioned there. And then the bandwidth. Next, here you can specify the storage arrays that you want to associate this policy with. I'm going to select both. Next, and finish. So the policy just got created. So now let's see how we can associate this policy with the VHD. For that, we have to create a VM. So I'm going to just say create virtual machine. Let's create it from a blank VHD. Next, demo cost VM. I want to make this highly available because the array that I'm going to use is associated with the cluster. So I'll just check this, again, a single checkbox. Next, select the destination. I associated with both the arrays, so I can select any host as long as I have the all hosts. OK, that's better. And so let's say I select host 2, go next. Now, if I come to the hard disk, you will notice that it is using the clustered shared volume, volume 1. And here, you can see the demo policy that we just created. Next. Next, and done. That's it. So you created the policy associated with the storage arrays and created a VM and applied the policy to the VHD of that VM. Back to the PPTs. The third one about storage is about replicating the volume synchronously. This is another differentiator for Microsoft. So basically, storage replica is a feature where you can replicate storage volumes to avoid the need for expensive SAN-based replication. This can be synchronous or asynchronous. VMM today supports only synchronous. We'll add support for asynchronous soon. This is how it works. So if you have VMM managing, let's say, 2 clusters, one cluster might be using SAN because you surely can use S2D and save on SAN cost, but you might have already some SAN that you have bought, right? And now you can take a volume from that cluster and replicate it synchronously with another cluster which is set up as a storage spaces cluster. So this is destination 1, right? You can really save a lot of cost because you're not paying for SAN. You can go across VMM installations also. So basically, you can have one site with one VMM server, another with another. And Azure Site Recovery, or ASR, can orchestrate this for you. Just a note here, we do not have this support quite today, but we will be adding this support both to VMM and ASR soon. So essentially, you get storage agnostic synchronous replication. So it doesn't matter what kind of storage you have, either on the source side or on the destination side. Let's take another turn. So far, are you with me? Am I going too fast? OK. Go ahead, please.
Yeah, I had a question about the QoS policies in which
OK.
How does it apply to the external SAN, which is in the storage areas created using Microsoft?
Right. I mentioned SOFS, and there was a reason for that. Today, VMM supports the QoS policies, the storage QoS policies, only for SOFS-based clusters. But at the platform level, it is enabled for SAN also. Now, how exactly it happens, I don't know, and I don't want to misspeak. But Klaus, who is delivering the other session, can give you the details. Or if you come talk to me afterwards, I can connect you with that. But I verified by going through the TechNet documentation that you can do it for others. OK, so SDN, this is another software-defined part. This is an interesting topic in and of itself. It was quite hard to find definition of software-defined networking, actually. You try to find it. So this is the simplest that I could come up with. So basically, right, it is abstraction over the physical network so that your workloads or applications do not need to worry about the nitty-gritties of the physical network. And for the administrators, right, they don't have to sort of configure switches and routers. All of this can be done in software itself. So SDN has 3 main components. There are many others, but these are main. Network controller, this is a centralized control point. This is sort of a brains of the SDN. It's also called control plane. And then there is a software load balancer. So instead of using hardware load balancers, you can balance the tenant traffic using the SLB or software load balancer VMs itself. And then there are gateways. Gateways are basically to enable the cross-network connectivity. So if your VM wants an outbound internet connection via NAT, you can use these. So how does VMM come into the picture? So in 2012 R2, this is how the stack looked like. You had network virtualization. This was HNV or Hyper-V network virtualization V1, and then which was the data plane. And then you had VMM, which was both the control plane and management plane. And then the way you distinguish between the two is the control plane is the entity that enforces the policy. And then the management plane is where the user defines the policy. With 2016, there is a separation of planes. So the control plane is now the network controller, which is a component in the Windows Server 2016 OS itself. And the management plane is in VMM 2016. VMM 2016 will support both the modes. So if you have pre-SDN environment, you can configure and use it using VMM 2016. And you can also have a SDN environment. Load balancers in Windows Server and VMM 2012 R2, you had to use hardware load balancers. Now you can use software load balancers. You don't need to spend big dollars on the hardware load balancers. Gateways in 2012 R2, these were cluster-based gateways. So you would have like 2 node clusters so that you have high availability for each of the gateways. 1 node typically will be active, or 1 would be passive. You do get high availability, but you end up using a lot more VMs. If both the VMs in this diagram go down, right, then your gateway is not available. In 2016, these are pool-based gateways. So you have a single pool, and there are, like, in this case, 5 active sort of members of the pool and 2 in like standby. So even if 2 go down, you are still fine. And with fewer VMs, you are able to achieve higher availability. So this is all the functionality which is provided by Windows Server 2016. Where VMM actually comes into picture is that you can deploy these infrastructure components very easily using the service templates. These are the multi-tier application deployment thing that I was talking about. So let's build up this SDN infrastructure in the slide, and then I'll quickly show a demo also. So here, right, you have 4 hosts. You will start with the 2 physical NICs. You can team those, and 1 management logical network. So this is the network for your management traffic, meaning your Active Directory, your DNS, your VMM server is talking to your host over this network. Okay? Then you will deploy network controller. This was the brains of the SDN. Okay? And this deployment is, again, the service template deployment. The creation of 3 VMs, making sure that everything is set up, will be taken care for you. Then you create two more networks. One is transit network. This is for the connectivity to the external networks. And the other one is called as HNV provider network. So these are the provider IP addresses on which the encapsulated traffic of the tenants go over. So once you have this right now, you can create VM networks. And these are the networks for the tenants. So the tenant can say that I want to bring my own IPs, and I want to create the VMs there, and they should be able to talk to each other. In this case, there are two tenants, tenant A and tenant B. If you notice, the IP address space is overlapping. And that's OK, because network isolation is one of the features of SDN. It is getting too crowded, so I'm just going to remove the background to keep things simple. So now you have your network controller deployed. You have tenant networks created. Now you can deploy SLB, software load balancer, again using service template. And then you can deploy gateway for cross-network connectivity. So finally, this is how the picture will look like. This exactly is the picture that you will find in the TechNet documentation. Obviously, it doesn't build up the slide, but I wanted to make sure that we go through this step by step. Because the first time anyone looks at this slide, right, I see, wow, this is very overwhelming. So let's take a quick look of how you can deploy these SDN components using VMM. So I'm going to go to library and look at templates. So I have these service templates here. These service templates are available on GitHub. You can download those. And there are some resources, custom resources for like certificate, for cert-based auth, and whatnot. All of those you can just download and import to the VMM library. It's a very straightforward process. So this one is for network controller. There is one for gateway, one for service software load balancing. And once you have this, then you just say configure deployment. You can say demo NC is the name of the service that you create. I'm going to put it on all hosts. Now it will show you this service deployment screen. And here you can see that there are a bunch of parameters it asks so that it can deploy the VMs. Some of these might be the local administrator username and password for the NC VMs, the network controller VMs itself. If you refresh the preview, then it will go ahead and run the placement and find the right host for these NC VMs. You can change the settings like the name, VM name, the computer name, and whatnot. And after that, you just need to deploy service, and it will go ahead and create the VMs, make sure that those are placed on the right hosts and whatnot. So Jason Messer had a session yesterday called From Zero to SDN in 60 minutes, where he walked through deploying the network controller, then gateway, and SLB. You really need a dedicated session for just that deployment. So I'm going to cancel this in the interest of time. However, I do have these all three deployed in my environment. So I'm going to go to services view for all hosts. And here you can see that I have a 3-node network controller deployed, and same for gateway and SLB. I just have 1 node SLB and gateway, but you get the point. So the whole idea is that the deployment of these SDN components has been simplified for you. OK, time for another trivia. I hope you're enjoying these and not feeling overwhelmed. So if you had to visit the newest country in the world, what would that be? Anyone? Sorry? Ecuador, no, sorry. Anyone? Okay, it's South Sudan. It declared independence from Sudan on July 9, 2011. Okay, so now let's look at another thing. We are still in the networking area. So how can you control the traffic coming in and out of the tenant VMs? So the feature is called port ACLs, or port access control lists. Basically, you can centrally configure and manage the Hyper-V switch port, Hyper-V port ACLs to control the in and out VM traffic. So port ACLs, basically think of these as network security groups. Just like you have OS level firewall, this is at the network. In VMM, when you create a port ACL, basically it is a bag of rules. These rules say which port, on which port, whether to allow the traffic or not. And these port ACLs get associated with the VMM primitives. And these primitives are the VMM server itself. You can say that, OK, this is my sort of a global setting for all my networking objects within VMM. Then at a network level, similarly at the subnet level, and at the virtual network adapter level. You can associate only one port ACL with, let's say, network adapter or subnet. But since there is this sort of hierarchy, right, there is a chance that a rule in one port ACL can conflict with a rule in other. For example, on one, you can say that allow access to port 80. At other level, you would say no, deny access to port 80. Maybe you just want to do 443. In that case, this is the order that's followed. So if you have something defined at the VMM server level, that takes precedence over others. So basically, it's quite straightforward. So let's jump into the demo. So for this, let me show you something. So remember, I showed you the network controller deployment. After that, what I had done was I had created two VM networks also, one for tenant A, another for tenant B. And if you notice, the IP range is overlapping. Okay? I also went ahead and created bunch of VMs. So tenant A, VM1, VM2, tenant B, VM1, VM2. So if we look at tenant A, VM2, it is 192.168.0.5. Similarly, tenant B, VM2, 192.168.0.6. So overlapping addresses, but these two are entirely different tenants. One can be red tenant, other can be blue tenant. Okay? So for the port ACLs, I'm just going to start tenant A VM. So power on, okay, and I'm going to connect to that VM. Okay, let me log in. Let me get this out of the way. Okay, so I am logged into VM01, and from here, I'm just going to RDP to tenant VM2. This is the IP address we saw. And I'm able to RDP to 192.168.0.5. And you can see that this is tenant VM2. So now I'm going to close this. And now what I'm going to do is I'm going to start a PowerShell session, VMM PowerShell session. And I'm going to run through a small script. Okay? So the first, I'm going to get the VM. The tenant B is VM2. Next, I'm going to get its network adapter for, it has only one network adapter, so the code would still work. Ideally, I should have enumerated all and then pick the right one. For demo, probably it's OK. Then let's create a port ACL. This is sort of the bag of rules that I talked about. And then let's create the actual rule. And if we look at the rule, right, The rule has a name, and then this rule will be part of the port ACL that we just created. The port is 3389, which is the RDP port. The action is deny, and it has a priority 100. So this priority is that it's sort of a system where the higher the number, the higher the priority, what can I say? The lower the so basically, this priority is used to evaluate the rules. And then we are going to set this rule we are going to associate the port ACL with the virtual network adapter of VM2. So what we did just now was for the VM2, the network adapter, we said we are not going to allow RDP traffic from anyone. So let's go back and take a look. So I'm on VM01, and now if I try to RDP, let's see what happens. If it's taking time, in this case, it's a good sign, actually. OK, so you just block the RDP access to that VM. OK, how are we doing on time? OK, not bad. Virtual switch, I don't think so. Virtual switch enforces those. But you can apply it to the VNIC, the network adapter, or to the subnet, or to the network, or to the VMM server. OK, last stop of the journey. Deploy minimal footprint server. Anyone heard about Nano? Hopefully everyone. Yeah. OK, so what is Nano? What is Nano Server? Nano Server is a new deployment option in Windows Server 2016. It is very lightweight. Last time I checked, it was like 400 MB footprint. Obvious benefits, since it has low footprint, the resource utilization is much better, fewer reboots because there is a need for fewer patches and whatnot. What VMM brings to the picture is that you can go from bare metal to compute cluster, or bare metal to storage cluster, which is based on Nano using VMM. So we talked about S2D clusters. You can have a bunch of bare metal machines and go through that wizard, and at the end get the Nano server-based storage cluster, S2D cluster. For the VMs, there is nothing that really changes. You create the VMs as you have been creating those. Instead of regular VHD, the full server VHD, you can use the Nano VHD. Couple quick tips about Nano. So for the operating system deployment, when you create the Nano VHD, you have to make sure that all the right packages are already there. I have listed those here just so that, especially you will see that there is a VMM agent, because if that package is not there, then VMM won't be able to manage that host. Another tip here, the VHD for Nano host and Nano guest, the way you create it is different because the drivers are different. And finally, I see many people saying that, OK, I'm going to use the Nano SKU, or stock keeping unit. Nano is not really a SKU. It's an installation option. So if you buy Windows Server Standard Edition or Enterprise Edition, in both, you will get Nano. That's not the case with like SDN or shielded VMs. Those are there only in Enterprise Edition. But it's basically you have full server as an installation option, core server, and Nano server. So just a quick mention of that. Let's take a quick look at this. This is a very simple demo. I was considering whether to show it or not, but thought, why not? So let me go to the VMs and services view. One thing about Nano is that you cannot RDP to Nano. So you have to use sort of PowerShell, and then there is something called as SMT, the server management tool, which is part of the Azure that you can use for nano management also. But you can console connect to it from VMM. There is something called as recovery console. So if you have a nano VM and do a console connect, you can basically connect to it. Oh, see, this is why I don't like typing in front of, I don't know, 100 people. You can log in and do like basic troubleshooting or management. So that's pretty much it for the nano. Okay. So to summarize, we quickly covered the VMM 2012 R2 overview, and we took a VMM 2016 journey for managing the software-defined data center. So these are the 8 stops of the journey that we took. You will notice that the city names have changed, which is not that uncommon, I would say. The earlier names were more like benefit-oriented, like tamper-proof VMs, and then zero downtime, and cost-effective clusters. These are more buzzword-oriented, like shielded VMs and S2D, SDN. Regardless, right, the journey still remains the same. So in a nutshell, right, VMM 2016 caters to today's IT demands. May it be like saving money, saving time, enhancing security, increasing effectiveness. And in today's journey, we covered only some of the features. There are many more in VMM 2016. For example, highly available VMM upgrade with near zero downtime, switch embedded timing, which I didn't get into, modifying running VMs, production checkpoints. Some of these are mentioned here if I click it. So I firmly believe that VMM is no longer a virtual machine management product. It started with server virtualization, but now with the support for network virtualization and storage virtualization, right, it has really morphed over the years into a virtualization manager product for today's software-defined data centers. With that, I hope you enjoyed the journey as much as I did. Thank you for your time. Please do provide the feedback and enjoy the rest of the conference. VMM, so the question is, you can use the mic so that it helps the listening audience. I will repeat the question. Does VMM 2016 support P2V or physical to virtual? The answer is no. The P2V support was removed, I think, in VMM 2012 R2 itself. So we have not added it back. So there is a tool called MVMC, Microsoft Virtual Machine Converter, that has that support, but that tool is going to be there only for an year or so. We have made that announcement. ASR, Azure Site Recovery, is the solution that you look into for physical to virtual. Okay. Okay, looks like there are small questions, so I would just come here and then we can discuss.